to get away with murder. All right, not literally, more like copyright-wise. All right, here we go. So we're watching Con in order to prepare for, if anyone's gone today, prepare for section 6.1 and making a huge deal. Why am I talking about him? The AP is coming. Ask me more details later. All right, here we go. Marks, set.
Find the area of the region in the first quadrant right over here.
Don't fall asleep
That's
from his
below the graph of
He has
y
no
equals
knowledge.
square root of x, but above the graph of y is equal to x squared. So we're talking about this region right over here. And we know what the two endpoints are. The two endpoints are when these two functions equal each other. So x squared is equal to square root of x at 0, at x is equal to 0, and at x is equal to 1. So how do we think about this? Well, one way to do it is just to think about, well, what's the area between y is equal to square root of x and the x-axis? So that's going to be, and we're going from 0 to 1. So this is the area under square root of x from 0 to 1, dx. So this is literally denoting this entire region right over here, all the way up to this boundary point, so this entire region. And then from that, subtract out this region, the area underneath y is equal to x squared, but above the x-axis. So from that, we could subtract from 0 to 1, that's the interval we care about, the area under x squared, dx. And this would be completely legitimate. And you might say, hey, look, I have the same boundaries of integration. I have dx right over here. Couldn't I have also written this as, could I have not also written this as the definite integral from 0 to 1 dx of square root of x minus x squared? And if you ask that, I would say absolutely. And this is actually a different way of conceptualizing it. Here you're taking the area, and instead of, if you conceptualize dx as the width of each of your rectangles, dx is the width of the rectangles. Now the height of the rectangle isn't just the function between the x-axis and the function itself. The height is the difference between the two functions. So in this case, this would be the width of a rectangle, and then the height would be the difference between the two functions. And then you would have another rectangle right over there. All of them have width dx, and then the height is the difference between the functions. And then as you take the limit, as you have super thin, as these rectangles get thinner and thinner and thinner, you have more and more and more of them, you are essentially approximating the area. So this is one way of conceptualizing it, or just using, I guess, the tools we already had, the area under the curve of square root of x, subtracting from that the area under the curve of x squared. These are completely legitimate ways of conceptualizing it. But now let's evaluate it. So what's the antiderivative? We know from the second fundamental theorem of calculus, we can say this is right over here is just going to be the antiderivative of square root of x. Well, square root of x is the same thing as x to the 1/2 power. So we just increment it. So we say x to the 3/2 power, and then divide by 3/2. Well, that's the same thing as multiplying by 2/3. And we're going to evaluate that from 0 to 1. And from that, we subtract the antiderivative of x squared is x to the 3rd over 3, and we're going to evaluate that from 0 to 1 as well. Now, this first expression, if we evaluate it 1, 2/3 times 1 to the 3/2, that's just going to be 2/3. And then from that, we're going to subtract this thing evaluated at 0, which is 0. So we're just left with 2/3. And then we're going to subtract this thing evaluated at 1 minus 1/3. And then also we're going to subtract this thing, well, just to be clear, we're going to subtract this thing evaluated at 1, and then from that it evaluated at 0, which is just a 0. But this whole thing simplifies to just subtracting 1/3, and there you have it. We get our answer. 2/3 minus 1/3 is equal to 1/3. So this area right over here, whatever units we're using, is 1/3 square units of area.
Okay, so I want you guys to help me solve the problem. How could you find area between curves? Let me go ahead and go turn on the light. First of all, whenever we're thinking about area, question, kiddos, what do we need to think about? Integral, true? And what are the two curves? What are the two functions that we're dealing with? X squared and square root of x, right? Why did he deal with them separately? Why did he deal with them separately? Because they're two different functions. But why did he use subtraction in between? Because we're trying to find area between. Hey, someone's taking the SAT. At least one someone's taking the SAT on Saturday. So question, help us out. Where have you seen area between before? Thinking about SAT math? Lines and stuff. Wait, no, that's not right.
All the shapes that are in the
area
square.
Yes, lines and stuff.
Lines and stuff? What are you talking about?
Inscribed shapes.
Inscribed shapes, right?
Lines and stuff.
That's not a line. Oh, it's close. Can I go a little further and then move it? Let's see. If you're trying to find, now what's something that SAT would totally, well, not totally, but has totally, may totally ask? Well, because I'm using the shapey thing. Yeah, what if they say find the shaded area, right? Something like this, and it's like, hey, find the outside area. It's area between, true?
Yes.
Okay. Now, what do they have to tell you in order to help you find area between?
The radius of the circle.
Okay, yeah, this would be an easy type question. Yes, of course they get harder, but let's just say they say that this is 5.
And then you could find the side of the square is 10.
You can figure out the side of the square is 10. That's good. What else could you figure out?
Area of the circle.
The area of the circle, because the area of the circle would be pi r squared. So I could do minus 25 pi. Wait, what?
Yeah, that works.
Oh yeah, because r squared, that'd be 25. 25 times pi, there we go. And then what would the square be?
It'd be 10 squared.
Because 5 and 5, if it's a true square, the side would be 10. So we'd have a 10 by 10, and 10 by 10 would be 100. So it would be the area that's inscribed. Hey, speaking of which, hold on. There's a pi in this problem. Question, what day is today's date? It's March 9th. 309. Is there a special day for math? 314. When is March 14? Do we get pi? Tuesday. Should we celebrate Pi Day?
Yes.
I think so too. That was me. Last year we were too disorganized. We didn't do the big old pizzas in the gym last year, did we?
Yeah, I thought
Yeah.
You made pie
Oh,
shapes.
that's what I did
They were
instead.
so yummy.
They were yummy. They took forever. Instead of making pie cookies this year, because that's not going to happen probably, instead it's been a while since I had kids bring in pies. That'd be fun. Bring in circular, well, here's the dealio. If you bring in a circular object for us to do a pie potluck, a potluck of pie. Anyway, a pie potluck. Why is it just circular?
Circle.
Because you could do the play on word and actually bring a pie, but if it was all pies, that might get kind of overwhelming. Couldn't you also bring like a circular coffee cake? Oh my goodness. Or like a donut? Or possibly what? This could work. They're circular.
Frisbee.
Anyway, if you bring a circular snack for our circular snack? A circular edible? How about a circular edible? A circular, that's bad. Something that's, why does every word in today's culture have a negative connotation? Anyway, you guys are so annoying. A circular snack that you can eat. Probably, to be completely honest, we should shy away from homemade. But if all you can do is homemade, I understand about pie cookies last year. But if you bring in something circular, you can bring a pie, you can buy cookies from the store, you can bring in, what else is circular? Crustables are circular, what protein? So here's the dealio. Here's the dealio. I'll make coffee. I'll make coffee, and if you bring snacks that we can share, I will give you, I don't know, what should I throw in a bonus? Something.
10 points.
5 points.
Actually, 15.
Retake on yesterday's test.
We'll see. I'll throw in 5 bonus points somewhere where it'll help. How about that?
Retake.
In the test category. 5 points in the test. Wait, would it be first period?
Anyway, Friday, Tuesday, bring in something to share.
Is it first period or what time? Where? What?
It's to class. Sorry guys, iPad's still not working. I don't know how or why. So you guys can talk it out. Pancakes are circular anyway. Depending on what your period falls, you guys in the morning, you might bring morning snacks. People in the afternoon might bring more afternoon snacks.
Rough plates. So we need plates to eat.
I was actually going to say on Monday, I will take volunteers, only on Monday though, I will take volunteers to sign up for bonus points for napkins and plates and utensils.
More bonus points?
On Monday.
Wait, can you give more bonus?
I'll bring toothpicks.
Instead of bringing snacks. But I'll do that on Monday, because we're not set up for today. Here we go, kiddos. I apologize for having to do it this way, but it is what it is, and it is what it is. Okay, so it's a little bit annoying because I wanted to zoom in and stuff, but the iPad was being done. I need you guys to help me out with how to solve. So we talked about things like subtraction. We talked about things like treating them separately. Sorry, I know it's super annoying. I have to go with yellow just because that's awkward. I apologize. Okay, so everything's going to be in yellow. Low stand up. This is on my iPad. It'd be nicer. Question. What or where do I start? Go. First of all, what do I want? Which area?
Between.
Ooh.
I know, but it's all going to be yellow. Sorry. Okay, so area between. Actually, I don't have to do yellow. Keep going. Area between. Question. Area is an integral. So where do I start with integration? Why am I doing 0 to 1? How come you did that? How come you did that? Okay, but he put a little 1 there. That's all well and good. How can you prove to me that 1 truly is the point you should put? Why couldn't it be like 0.9? Because this is what? An intersection. So if you were to need to prove to me, you could set x squared equal to square root of x. What would you do to both sides? Square them. And you would end up with x to the 4th equals x. Then you would say, oh, hey, divide both by x, x equals 0. Wait, where does 1 come from?
If you plug in 1, they both equal each other.
You should always think factor, not divide. You should always think factor, not divide. Subtract the x, factor out an x. Now can we prove that we have 0 and 1 as our intersections?
Yes.
Yes. There's 0, there's 1. Okay, anyway, 1 was the correct upper bound. Good job. Because we have an x from 0 and an x to 1. 0 to 1 of who, though? Why should square root of x come first? It's higher, which means its area is greater. Does that make sense? Okay, and if we're trying to find just the between, we want to do the greater, the bigger, minus the smaller, so we have the positive area in between. Area between will always be a positive. If you get a negative answer, you probably switched the higher and the lower. Just think absolute value. We'll get to that today. When you solve for the area underneath square root of x, what area are you actually finding? This one. Now, is that what I actually want?
No.
No, but think the square. It's just a little bit too much. How do I finish off the problem? I think about the area of the other one. Who is the other one?
X squared.
X squared. Well, that one actually matches. Okay, so area of x squared. What am I going to use as my bounds again? 0 to 1. And what area is that going to find? What happens if I take the red minus the green? I get the yellow. I get the in-between area. So how do I finish off my formula? I subtract the integral from of. And after some quick mathematical computations, aka using, he said the fundamental theorem of calculus part 2. Remember I said different people name those different parts differently. Some people say the derivative of the integral is FTC part 1. Some people say f of b minus f of a, the antiderivatives is fundamental theorem part 2. We did it the other way because that's how my book originally did. Either way. By the fundamental theorem of calculus, we are able to solve, and do you guys remember what he ended up getting?
Yes.
1/3.
Why do you think I'm not going to spend time? I wouldn't say waste time, because some of us could use this practice. Why am I not going to spend time solving? It's review. It's review. Does that make sense? Okay. So, do we have the answer to this question, the area between for this problem? Dun, 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 dun. Let's see if you guys can keep doing it real quick. Things get different, so we have to have a broader understanding than this one example. However, some of you are like, hey, I really, really got that. Maybe it's because you watched a video and you heard an explanation. Maybe you should be implementing this in your study. True? Yeah, Katrina. Can I open the door? One more time? Can I open the door? Yeah. I think the timer got messed up. Remember how the bells were off that one day?
So
I think it's thinking that we've already gone on the time change and we haven't, so it's letting the heater, like it's on auto, but it doesn't switch until a certain time. Oh,
the 12.
spring forward.
Then we got there an hour.
Yes.
Yes.
That's kind of nice, because that means it'll be lighter.
So like more golden hours.
No, we get less. Most of you won't even know. You just wake up and your phone says, and you're like, all right, whatever, let's go. Not the whole, like, go around the house and then set the whole thing.
My grandpa stays up until it changes. Like a celebration.
Kiddos, wait. Why is intersections up there? Natural bounds are going to occur at intersections. And Corey, you already talked about it in the last example. How do we solve for intersections? Set the two equal to each other, right? Set the functions equal. Can I just say that? Using cursive law still can. You guys can read it. Elementary kids can. Set functions equal and solve. Question: do functions only intersect in one point? No, that one didn't. It intersected in two. Could it intersect in more? What kinds of functions only intersect once? If they intersect at all? Linear ones. Right? There's no curved line unless you're in like a different dimension. But coming back. But any other function, quadratics, cubics, we're going to have to remember the basic graphs from Forever Card number. Yeah. Or is it two? You know, the beginning ones. So, question. Question. I have two different bullet points, right? So if this one says defined bounds, aka given bounds, question, what do you think natural bounds are not? Given. Yeah, they're not given. You have to figure it out yourself. So if no bounds are given, if no picture is given, and if no interval is given, like if you, as you guys are writing the defined bounds, sometimes they'll say from x equals a to x equals b, or maybe even y equals a to y equals b. It's defined differently. If they don't give you words explaining the interval, as you guys have already seen with definite intervals, sometimes they give you this wording. You've already seen with area also. If they don't give you words and if they don't give you a picture as far as the bounds, that means we're setting the functions equal and solving, looking for intersections, okay? Steps. You're already writing. If you solve it the way Khan solved it, the way Sal solved it. Khan sounds better if you know who that is. Must identify which curve. If you solve it his way, you have to know which curve is most positive. AKA either highest, because that will be the greater area minus the smaller area, one that's lower, function or curve that's lower. Or the curve that's farthest right. if instead of dx you have dy, you might have right-left orientation instead of up-down orientation. We'll get there. Highest or farthest right would be the most positive. You must identify the bounds. But then just figure out, okay, is it natural, so I'm finding intersections, or is it defined, so I just steal what they give me? And then you must split up integrals if curves ever switch order. Let me give you a quick example of what that could look like. Ready? What if I was to give you something like a sine curve? I'm not going to write which sine curve to make this a special one on purpose. It's been transformed, stretched a bit. And let's say we had a parabola. And let's say we want the area between. Things just got a little more complicated, right? How many different sections of area between are there? See it? There are 3 different areas between. What if you only looked at the first section and you said, oh, of course, the trigonometric one's on top and the parabolic one's on bottom? And what if you make one grand integral and you just say, okay, the trigonometric one minus the parabolic one, and you go from the farthest left to the farthest right? Why is that a problem? Yeah. But what does that end up, how does that end up messing up our answer? What kind of answer, as the integral is accumulating, because remember it adds up to infinitesimally thin rectangles, and technically it's going to do the higher rectangle minus the lower rectangle, what kind of sign will all of these accumulate to be? They're accumulating positives, right? Right here, what sign is it going to start accumulating? Negatives. So if you're accumulating positives and then you start adding negatives, what happens to your value? It decreases, and then what's going to go on here? Accumulate some positives. But what are they actually asking for? Are they asking for add all the positives and negatives? No, it's a geometry SAT problem, kind of a lot harder. They want just, what is that number that represents all of that area? They want absolute value. If they want absolute value, they want that to be a positive, that to be a positive, that to be a positive. What's one way using Kahn's method to do that? Split it up. Go from this intersection to this intersection of sinusoid minus parabolic, right? Minus quadratic. Then, from this intersection to this intersection, parabolic minus sinusoidal, right? And then this intersection to this intersection, sinusoidal minus parabolic. Add them all together, they're all positive, good. But what mathematical operation, function, would do that for us? I said it earlier in my description. Starts with an A. Ends with a salute.
Absolute value.
Absolute value. Right? Sarah. Oh, it goes negative because if you think, remember we're taking the area of the rectangles going to green minus the area of the rectangles going to red to find the in between. That'd be a higher or a bigger number minus a smaller number, positives. So all of these will be a positive, positive, positive as they add up all those rectangles. And when you go here though, this rectangle will be smaller minus bigger, negative. Does that make sense? And so it's going to add positives, add positives, now it's going to start adding negatives, so it's going to actually take away from the overall instead of adding to it. Or no, Katrina, I just saw a hand back there somewhere.
How would you take like the absolute value of the entire thing?
Exactly, but what does absolute value tell us we have to do at intersections? So we're going to split it up either way, but one way we have to know who's top bottom, the other way we say who cares, I'm just going to solve for it and make it positive and then add it to the rest. Does that make sense? So absolute value does what we need it to do. Let's keep going. That gets us to, oh no, we're not to a card yet. We're almost to a card. One more example. I give you somebody else. I give you x squared and x cubed, and I just say find the area between with no picture. In this section, as much as is possible, we need to not use our calculators. As much as is possible. Sometimes we can't use our calculators on these types of problems. As much as is possible. Meaning, for these functions, they would not expect you to use your calculator. X squared and x cubed? Nah. But the problem is, if some of you were to draw this, you're too used to just sketching. It could get you in trouble. Because you could say, no big deal. He's going to be my x squared. He's going to be my x cubed. X squared does something like this, and x cubed does something like this. Yay! What is the area in between? It's infinite! No. Maybe we shouldn't have just kind of eyeballed it. Now, we could be super precise and start making tables. Or we could just say, hey, they didn't tell us bounds. So what does that mean? How? Find the intersections. If there are any. And maybe that'll be the key to figuring out the graph. Intersections, if I set x squared equal to x cubed, some of you hopefully took to heart what I said by factor, don't divide. And when you pull out an x squared, you get an x, nope. Apologize. Not in teaching factoring algebra 1 right now or anything. What's x equal? Wait, so they intersect? Where? Plug it in. 0, 0, and plug it in. 1, 1, right? 0, 0, 1, 1. So, hold on. There and... they intersect? How? Well, I guess the cubic one... Oh, cubic one's supposed to be blue. I guess the cubic one goes that way. And what else goes that way? Who ends up growing faster? The cubic, right? So, this needs to somehow be... No, that's not going to work, right? Because if I cross here, isn't that going to go higher? Just using my knowledge of graphs, what's going to end up happening? Something like that. No, it's not super gorgeous. How can we make it better? I don't know, plug in things like 1/2 and 1/3 and 1/4 and then graph it. Or we could just say, well, cubic has to end up on top, so I know somehow it goes like that. And once again, why are we doing this? Well, we're trying to visualize, right? The area between. Why are we trying to visualize? Because we're trying to do it Kahn's way. Now, I'm sure he probably shows the trick. I'm about to show you. I've already alluded to with absolute value later on. But if we were just to do it the visual way, we would have to know who's on top. And from this, we can now say which one is greater, which one has a greater area on his own. The quadratic for that interval. So I would end up doing it his way. The integral from 0 to 1 of the x squared dx minus the integral from 0 to 1 of x cubed dx. A few of you are annoyed because I randomly switched my colors, and you're right, I apologize. There we go. Okay. However, even though that's valid, you guys saw him put this together as one integral. We can solve it separately, we can solve it together. If I was to make it one integral, I could do x squared minus x cubed. It would mean the same thing, right, cool kids? The question, what if I didn't feel like drawing a picture? What if I didn't feel like drawing a picture? And I found my bounds, and I'm like, I don't really care who's on top because I know math and something can fix all of this, whether or not I get it right. How can you do this minus this and have it still be right? Wait, no, you should have put the absolute value on the inside. Well, I could have, but I didn't need to. Why? The only time we can't pull the integral, the only time we can't pull the absolute value out is when? What do we have to do before we can pull the absolute value out? Check for. Remember? Continuities. Zeros. Check for zeros. Wait, how would this be a zero? If they equal each other. If you've already found your intersections, guys, there's no intersections in between the intersections. We already found the only possible one, so therefore it's a nice trick. Since we've already found the intersection, pull it out. Solve. I think you can do a good portion of your homework, but if I were you guys, look at notes and copy down your forever card. Copy down your forever card and then go. But we're going to do more examples tomorrow of how it will get tricky. Homework should be online by. I'll try a lot. Bye guys.
Just keep it thin.
Once you have it solved for the balance and then you replace it out.
The ones that get weird are the ones in terms of y.
Jump into the box.